What I'd like to do now is talk about the broader issues of how to avoid common programming mistakes when you use Java streams. And it turns out that there's a number of things people get wrong when they do streams, be it sequential streams or parallel streams. So I thought it might be helpful to kind of talk about some of those traps and pitfalls and see how we can avoid them. If you want to learn about this, there's a nice link at the bottom of this slide that talks about 10 subtle mistakes when using the Stream API. And we're going to talk about a number of these common mistakes. We'll use our examples that we've covered so far, things like the search with sequential streams example. We may also go and look at some other examples we've looked at, like the Hamlet example and so on. But the point of this is that these are common problems, sort of independent of what application or program or case study you're looking at. So one very common mistake, which I actually noted in the frequently made mistakes video I put out recently, is don't forget the terminal operation. If you forget to put the terminal operation at the end of the stream, then it'll all compile, but when you go to run your program, it won't do anything. And this is a very common beginner mistake, and I've made that mistake myself when I was first learning to program with streams. So here's a simple example that demonstrates this problem. This is a piece from our Search with Sequential Streams program, just forgetting to add the terminal operation. So you can see how we go ahead and make ourselves a stream, and then we go ahead and apply the map, intermediate operation to that stream, and then we have a semicolon, and that's it. So needless to say, nothing interesting will happen here. Another thing to remember is you can only traverse a stream one time. If you want to traverse it again, we'll see what you have to do, but you can only go through the stream once. It's something along the lines of an iterator in that respect. So here would be an example of what not to do. So as you can see, we go ahead as before and we make ourselves a stream and we apply the map call. So now we have a stream S. And then unlike the previous example where we forgot to put a terminal operation, this time we have two terminal operations on the same stream. And the first one will work just fine. It'll print out the contents of the stream. But unfortunately, the second one is going to go ahead and cause a problem. And in fact, what will happen with that second for each call on that same stream is you'll get the dreaded Java Lang illegal state exception thrown. And that's just an indication that you attempted to apply a terminal operation to a stream that's already been run once. So if you want to run things more than once, you're going to have to get a new stream from the data source or another data source or whatnot. So you only get to do this once. You only get to do the processing of the stream once during its lifetime. So make sure you remember that. That's another common mistake that I've also done too. Yet another mistake, which I actually haven't done, but I can see how it would be a problem, is modifying the collection that's being used to feed data into the stream while the stream is running. And so this example, you can see this coming out of the EX11 folder in my GitHub repository. And this is basically using the int stream, which is a specialization of stream. And what it's doing here is it's creating a range from 0 to 9, and it's boxing it and it's collecting it up into a list. So this particular code here is making ourselves a list of 10 integers in the range from 0 to 9. So nothing amiss at this point. Where things go awry is the stream down here. So we say list.stream, so far so good, .peak, we'll talk about peak in a second, and then we're going to have the for each call. So the idea here is we're going to be going through the stream and printing the results, but when we use the peak method, we're going to pass in a method reference or behavior, which is going to remove that element from the list. And oh my goodness, what a mess we are going to have. Because what we're doing is we're changing the backing collection as the stream is being iterated through internally. Now, peak is a very interesting method. The purpose of peak, it's really largely there for debugging purposes. Its goal is to have a side effect but not make any changes to the stream and not have any results that are going to be modified in the stream. So what we're doing here is we're passing in a destructive operation, basically remove, which is going to go remove that item from the list, but we're iterating through the list as part of the stream operation. So normally what you use peak for is for logging. You typically use peak to print out some interesting piece of content in the stream for debugging purposes. But of course, in this case, we have got a big mess, and it's not at all what we want to do. So chaos and insanity will result here. And in fact, you'll get some output, probably something like this. It'll print a few values, and then it'll print weird values, and then you'll get some concurrent modification exception because you're not allowed to change the underlying backing store, the underlying collection, while the stream is iterating over it internally. So you'll get weird results, and basically this is something called interference. And if you read the link at the bottom of the page, you'll learn about the concept of non-interference, and that's what you want to have in a stream. You just want to basically read the values, but not perturb the underlying backing collection. So that's a very serious problem. Another thing to keep in mind in the back of your head is that a stream holds no non-transient storage. And a good way to think about that is think about a sand castle on a beach, which is transient. When the waves come in, when the tide comes in, the sand castle gets washed away, no matter how beautifully constructed it will be. So the same thing is true with your stream. If something happens, if your program crashes or an exception is thrown, the data that's in the stream being processed won't be stored persistently. So if you want it to be stored persistently, then you have to persist it. So you'll have to use some kind of database operations, some kind of object relational mapping or something if you want to retain the contents of the stream. It's actually somewhat rare to want to maintain the contents of a stream while it's doing its processing. You typically would retain the contents of the stream after it's done doing its processing. But just be aware that the contents of a stream are stored in memory buffers, and those don't last if the program, the process the program's running in shuts down abnormally. Okay, so those are some of the things to remember. Those are some of the common mistakes. I've done a lot of those things, not all of them mercifully, but hopefully learning about this will help make you more effective when you write programs. And please feel free to go back and read that link that I have at the beginning that goes into more detail about all these different issues.